Okay, so continuing with our word problems for sector and segment areas, okay, for our last lesson here on geometry. Okay, so we have here this problem. Okay, Rex Steiner is a transportation engineer for a magnetic levitation firm, and he is planning to design a maglev tube from his hometown to Bulacan City, making the travel time for both cities significantly reduced to 10 minutes. So to accomplish this feat, the rough outline of the cross-section of the tube is given on the right. So we need to find the area of the segment length here of QX, shaded by the lime green given here for QX, and given that the radius is equal to 30 meters. Okay, so how can we solve for this problem? How can we solve for the area of this segment length that we have here? Okay, so recall that to find the segment length area, okay, the area of the segment, okay, to find the area of a segment, we have to first solve for the area of the sector. Okay, the area of the sector, this entire area of this slice, and QX, and then we have to minus, then we have to subtract the area of the triangle. Okay, so what triangle do we have here? We also have a triangle here. So this triangle NQX or NXQ. Okay, so how do we solve for the area of a segment? We just solve for the area of a sector, then we solve for the area of the triangle, and then we subtract their areas to get the area, the remaining part of this one. Okay, so to do so, okay, so we have here the area of this segment, QX. It's going to be equal to the area of the sector. Okay, so to find the area of a sector, we first have to get the area of the the measurement of the arc QX all over 360, okay, multiplied by pi r squared, or the area of a circle, minus the area of a triangle. So the area of the triangle here is going to be equal 1/2 the radius squared multiplied to sine theta, where theta is going to be the central angle. Okay, this is the central angle. Okay, so to solve for the area of the segment, we have, okay, area of segment QX. Okay, so this is going to be equal to, the measurement of QX is going to be simply 14. Okay, since the measurement of the central angle is congruent to the measure of its intercepted arc, which is QX. So 14 over 360 multiplied to pi, and then r is going to be 30, then squared, then minus 1/2, okay, 30 squared sine of 14. Okay, so solving first for the area of the sector that we have here. So this is going to be 14 over 360 multiplied to 900 pi. Okay, 900 pi. So that's going to give us 35 pi. And minus, okay, 1/2 of 30 squared, so that's going to be 900. So 900 divided by 2 is 450 times sine of 14. So that's going to give us 108.86. 108.86. And 35 pi minus the answer, so that's going to give us, okay, 35 pi minus 108.86. Okay, 35 pi minus 108.86. That's going to give us 1.10. Okay, so the area of segment QX, okay, area of segment QX, okay, segment QX is going to be equal to 1.095. Okay, or if you round off that number, okay, so it's going to be 1.10 squared meters. Okay, so this is the area, okay, going to be area of our segment right here, 1.10 squared meters. Okay, third problem. Okay, word problem 3. Mark Stephen, a biomedical engineer at Formlabs in the Philippines, plans to build a research facility for cancer and stem cell research with his team of biomedical engineers. So to do this, they would need to construct a circular facility given on the right. So given the rough blueprint of the circular facility that they will build, so we need to find the segment area of TR, this one, the one that's highlighted here on lime green. Okay, so how do we solve this problem? Okay, so if you will notice, we have here the central angle 115 degrees, and also we have this diameter. BT is a diameter, okay? So therefore, we can get the measurement of angle THR, this angle right here, so that's going to be equal to 180 minus 115. Okay, so 180 minus 115, that's going to give us 65 degrees. Now that we know the central angle for this part, okay, so we have here the central angle is 65 degrees. We can now solve for the arc measurement, and now also we can solve for the area of the segment that we have here. So the area of of segment TR is going to be equal to the measure of arc TR all over 360. Okay, so this is 65 multiplied to the area of a circle, pi r squared, minus 1/2, okay, r squared, the radius, multiplied to sine theta. Okay, so to solve for the radius, guys, we know that the diameter, okay, the diameter BT is equal to 70 meters. Okay, we're just simply going to divide 70 by 2. Okay, so 70 divided by 2, that's going to give us 35 meters. Okay, so therefore, the measurement of the radius HT, okay, or the radius here, that's it's going to be 35 meters. Okay, so area of segment TR is going to be equal to the measurement of arc TR, so that's just going to be simply equal to 65 degrees. Okay, 65 degrees, because we already know that the central angle is 65 degrees. Therefore, the measurement of this arc right here is 65 degrees. All over 360 multiplied to pi, and then r is going to be simply equal to 35, and then we square that, minus 1/2, then 35 squared, then sine of 65. Okay, so to solve for this problem, we have 65 over 360, and then we're going to multiply that to 35 squared, and then times pi. Okay, so that's going to give us, okay, 694.86. 694.8. Let's use 859. There you go. And then we have to minus. Okay, we have to minus 35 squared divided by 2, and then multiply that to sine of 65. So that's going to give us 555.11. 555.1135. Okay, so 694.859 minus the answer, so it's going to give us 135.75. And there you go. So that's going to be the area of the segment TR, 135.75 squared meters. Area of segment TR is equal to 135.75 squared meters. Okay, next question. Okay, next problem. Okay, Christian Carl and his other team of terraforming astronauts is planning to create a habitable space or a contained space colony on their way to Jupiter on ISS Haribo. So their team plans to create a vast expanse of habitable space colonies with a radius of 72 kilometers. Okay, so that's a very big space for a agricultural sector in space colony. So a portion of the said land will be for research and development industry, as highlighted by the lime green color. So this portion is going to be for research and development, and also for industrial and sustainable processes. Okay, so as highlighted by the lime green color on the image on the right. So we need to find the area of this given segment. Okay, so for this one, guys, so this is going to be quite simple. We have here that the central angle, okay, the central angle, okay, is given as angle GPD, okay, and we have here the arc, okay, the arc here, the intercepted arc of the central angle is 188 degrees. So therefore, the central angle here must also measure 188 degrees. And to get the measurement of this angle right here, this is the angle that we want to find, we simply have to subtract 360 from 188. And 360 minus 188, that gives us 172. So that means that the central angle here is 172 degrees. And we have here the radius is equal to 72 kilometers. Okay, so we have here theta is equal to 172 degrees, and the radius is going to be equal to 72 kilometers. Now we have to solve, and we can solve for the value of the area of the segment GD right here. So this is going to be equal to area of segment GD, okay, of segment GD is going to be equal to the measurement of arc GD, okay, measurement of arc GD all over 360 multiplied by the area of our circle, pi r squared, minus the area of the triangle that we have here, so that's r squared sine of theta, where theta again is the measurement of the central angle. So this is going to be measurement of arc GD, so that's 172. Since the central angle is 172, then its intercepted arc will also be 172. Then all over 360, then times pi multiplied by r, which is equal to 72. Then we square that. Then minus 1/2, then the radius, okay, we multiply to the radius, which is 72, squared, and then sine of, okay, so what's our central angle again? It's 172. Okay, so using our calculator, we can solve for the value here. 172 over 360 times 72 squared, and then times pi. So that's going to give us, okay, 7,781.096684. And then we have to subtract that from, okay, 72 squared divided by 2, then multiplied by sine of 172. So that's going to give us 360.73667. Okay. So we have to minus 7,781.096684 from the area of the triangle that we have here, a small triangle. So therefore, we're going to get a large area for the research and development and industry portion of this circular space column on Jupiter. Okay, so this is going to be, okay, a habitable space. Okay, so this is going to be 7,420.36 squared kilometers. Okay, so this is the area. This is the area of segment GD. The area of segment GD is going to be equal to 7,420.36 squared kilometers. Okay, next question. So Matt is a space materials engineer and is trying to create a portable teleportation device the size of a pizza and weighs less than half an entire pizza. Okay, so this is a portable teleportation device. The said teleportation device can disarrange and rearrange molecules and atoms or any elementary particles at perfect condition. So to complete the device, Matt needs to find the area of the segment here. So how do we do that? Again, we can use the formula for finding the area of a segment. But first, we have to solve for the central angle here. So if this is 333 degrees, so 360 minus 333, then we get the measurement of the central angle is 27 degrees, and the measurement of the intercepted arc SW is also equal to 27 degrees. Okay, so there you go. Theta is equal to 27 degrees, and the radius is equal to 9 inches. Okay, so solving for the area, the area of segment SW is going to be equal to the measurement of arc SW all over 360 multiplied by the area of the circle here, then 1/2 r squared multiplied by sine theta. This is the area of the triangle that we have here. So this is going to be equal to 27 all over 360 multiplied to pi times 9 squared minus 1/2 of 9 squared multiplied to sine theta, and theta is equal to 27 degrees.